and then adding the next one. So the next one will be here. And as you see that it's automatically changed the labeling. If I escape and select this one again, I can just change the dimension based on what it's supposed to be. And it's go all the way to the other side. So that way, I easily create my grid system. And then the floor plan is underneath this, so I know where each element is basically going. Okay, let's get back to here. So now I put this, and then after I finish with that, I can add the dimensions so that I remember that what are the different like span size that I put here. The next step in my work basically is adding the column and beam system to, or if I have like, for example, the load shear wall or load bearing wall, adding down those elements to my design. So in order to adding the column, I'm just keeping this here, but we'll go to, again, back to the Revit part. So most of the things that we were working with is under the structural tab. So I'm going to click on the structural tab, and this is the place that I would add my different elements. So at the first thing, I'm looking for my column, right? And I'm going to click on the column. The size, sorry, the size of the column, some of them is already here, coming from my previous research. So based upon the previous research, I know what is going to be the column size. Remember, I shared with you the table, the graphics yesterday, that depending on the span size, you can choose a specific, like for example, size for each category. But if you don't have, like for example, you decided to not going with the steel structure and you're looking for some other structural elements that you want to use, you can go and import load the family. So you can go to the load family, and then you can use going to the structural columns and find the columns that is right correct for yours. So you have a different type, like a concrete, like if I go using the concrete regular, I can just import that and overwrite the existing one. So I have that concrete rectangle here as well. Then I can choose like that a specific size that is close enough, and then I can edit the type just like the way that you did before, and you know how to do that. You just duplicate the size and add the size that you want. Let's say, for example, 24 by 24. And then here, I will change that. This is 24, the other one, I'm going to change it to 24. Now that the size and the type is right, the next step is that, I mean, if it is a small project, adding a column in different places would be easy. You just go here and click on the intersection between each of these grids. It will be relatively easy. But since the project has become bigger and you have a large project to deal with, it will be very hard to do that. So what we do here is that we use this add grids system. So if you click at the grid intersection, what you can do is that you can select all those grid, and the column will be placed on the right place, like without going and clicking on every places that you want. And then maybe some places you don't have a column, so you can go and delete that. But that way, it would be easier if, imagine I have like a 20 of them and all of them is the same size. Going over and clicking all of them would be tons of work. The other thing that you want to make sure is that when you are placing, before even going to the add grids, is the size, the height of that. So right now I have 2 levels, but basically you have 4 levels. So you want to make sure that you put the height into the right height that's supposed to go. And right now I'm in the top level, says invalid for that level. Okay. But you make sure that the height that you put is going to be in the right height that you want. So when you look at it into the perspective, you see that all the columns goes all the way to that levels that's supposed to go. All right, let's get back to, again, new share to the slide. So basically, if I want to say, this slide is going over the basic of the things that I just showed you. And then same thing. If one of the thing is that sometimes the column that you're using, it has a has a different like orientation that has to be like, for example, you have a W-shaped columns that you want it to be in the right orientation. So then you can use the space bar in order to rotate it while you want to place a column in the right place. Okay. The beam, I'm not going to go over the obvious, like what is the beam, but let's go and then see what you have to do for a beam. So the beam is also the same process. All right. So you go to the structure tab for the beam. So I'm going to talk a couple of times escape. I'm going to go to the structural level. And then for the beam, I'm obviously going to find the beam, finding the right beam size that I want. So like, for example, 12 by 12 or 12 by 24. Again, the size coming from your previous research that you have done. And then same as the one that you did for the column, you can do the same thing here. You can use this on grid. So, and then selecting grid and you placing your column in the right place. So if I go to the 3D view of this, oh, maybe I made a mistake, sorry. So I'm going to click on the beam, make sure that this is the right size again. And then here, I'm going to here, select them, and then press finish. So that way. All right. So then if I go to my 3D view, you see that I place my column on the right place. And I can do the same thing if I have a big area. Again, usually sometimes happen that you are adding them this way, and before basically some places you were thinking about changing the column so you can go fix one by one. This is like easier to manage the whole things at the same time, unless you have a different size for each of them. So it's relatively like a super easy, but the hard work for you is coming from the research that you've done before. The other thing, the other piece that you have to pay attention here, especially in the column, is that the coordination that you do with the architectural and mechanical elements. What does that mean? That means that, for example, I have my staircase and my staircase shaft goes up. If I can't cross that staircase with the beam system, because that way people walk running on the stairs and then just hitting their head to that beam that I placed there. So coordination between the structure and architecture is important elements here. The other piece is the mechanical elements, right? You have a mechanical system running around. Although we are not doing that at this work, it's worth to just think about those type of elements. Like, for example, if you have like a shaft or something, you want to avoid adding the column crossing that, because you want to clear that mechanical shaft for the ductwork and everything crossing through that. The other piece that you want to think about is the atrium, the openings, all those things. You are trying to avoid adding unnecessary and ugly, like for example, structural elements running around it, unless you have some like a design vision for that. Like for example, thinking about adding the beam in a exposed format. All right. If like for example, instead of like a regular beam, you want to add a truss, the process is not that different. The only thing is that you just use if I go again back to here, share, and I use the truss instead of like a regular beam. And usually the truss system is used in a place. The process is the same as how we did it for the beam. It's not that different. The only thing that you want to pay attention for the truss is that the obviously truss system give you a flexibility into having like a larger span. And maybe in places that you have like a big, like an atrium or something, you want to create that piece of like, or like for example, auditorium, you put the truss system in order to open up the space in that regard. So you want to taking advantage of truss system in those areas. So it's not going to be that much of a difference in terms of usage in Revit, but in terms of the architectural capacity that gave it to you, it's like a huge, like a difference in terms of the span size. Where was I? Okay. Then the next step is going to be adding the secondary beam system. So the secondary beam system obviously is not your main system, but if you place already, let's get back to the Revit part, and then I'll look back here again. If you have your floor plan ready, and guess you have like a larger span, and then the load that is in between these span has to be transferred to these like beams. Depending on the way that you are dealing with your floor system, you might have a secondary beam system or not. If you, for example, have a post tension like a concrete slab, you might not need it. But if you have like a different type of floor system, you might need a secondary in order to transfer the load from the floor to these beams here. So, and if right now this one is like obviously this span is 12, so it is in on both directions, it's the same size. But if I change this one, let's say for example to 20, just for the sake of conversation, you see that everything is just shifted and adjusted. And right now for my secondary beam, the secondary beam is gonna transfer the load to here and here. So this is gonna be my secondary beam, so transferring the load here, so breaking down that piece to this. So you have to pay attention in the way that where you want to place your secondary beam. What you can do here is that you can again use the automatic beam system, or you can sketch the beam system, secondary beam system that you want to have. So I'm going to have this one here and here, and then all the way down to this part and this part and this part. Let's say yes, and then that's going to be my secondary beam system that I was thinking. I can when I'm dealing with that, I can adjust the number, though, so I can say that they're supposed to be in a fixed distance from each other, or I can just say that they have to be a fixed number, or I can say that there is a maximum spacing between each of them, so or there is no spacing. So this is like if I change this one to fixed number, then the number obviously increases, and I can reduce that number. So the distance will be evenly distributed within that like a span system that I have. Same as the other structural elements that I have, I can adjust the sizing for this one as well. So I have to go all the way down. And I can go here and then select all these beam that I have, maybe multiple of them that I have here, and then adjust the type, the size. Again, this part is coming from your previous research that you do here. Okay, let's get back to make sure again. I'm gonna go back to my slides. So same as obviously secondary beam is not different than the beam system that you have. So the main coordination that you have to do is the coordination with your architectural or mechanical elements that you have to think about. If they are exposed, do you have any solution for that? Is it like in the middle of atrium? So these type of questions that you have to ask yourself. And again, here is like in the slide, I go through this part that I just go through, and I put it here for you to just like review when you want to do this part. Then we're gonna go to the foundation, right? So the foundation, same as what you did for the other elements, the placeholder for them is under the structure. You want to make a decision about if it is going to be the isolated foundation, or is it going to be the type of wall, like a foundation wall that you want to do. I already explained the difference between them. When you have like a separated column system in your floor plan, you obviously have the isolated foundation. But if you have like a shear wall system or like a load-bearing wall, that's the time that you try to basically adding this wall foundation system. So one of the things that you have to do before jumping into that part is that you have to go again for your one of your elevation, and under your elevation you have to go and create a foundation level for your building. So you create the foundation level. The basis of the foundation level is that it's usually between 3 to 4 feet below the freezing point if your level 1 is under the like a ground level. If you have a basement or something like that, the lower level of the basement is like a 3 feet below that part. But usually when you have like a put it on the first level, you have to have like at least 4 to 5 feet below the freezing point. So we're gonna call this foundation, and I'm gonna go here on my level 1 structural elements. I can either do it here, or I can go back to my view first, bring the plan view. I'm gonna go to structural foundation that I have and place the foundation. And then I need to go back to my level, selecting these elements, copy them, and then go into the foundation level and paste them. Paste them to the selected level. Yeah. Okay, so now that I have them under my foundation level, I can go to the structure, going to the isolated, and the size coming from your research that you've done. And then right now it's just a basic. If you want to adjust the size similar to what you did for other family type, you go here, duplicate this and adjust the size. And then here you place them obviously under the foundation, and you can either go with the same approach, clicking on each of them, or using a grid, selecting the grids that you want the foundation to be there, and then pressing OK. So to connect them all together. I'm gonna go back here again on the slide. Okay. I put here a very good video of like how to do these structural elements. This is like, I highly recommend to review that as well, in addition to this lecture and the slides. So it's like a very efficient way of like adding the structural system within your building. All right, so yesterday we discussed this. The other piece that you have to think about is obviously your lateral bracing of the building. If you remember, we discussed this, that you're trying to avoid the torsional irregularity in your building. That's a very important part. That means that the way that you distribute the bracing for lateral, and if you have your building, you have to have it for both direction, and you have to place them in a way that toward the center of your building, they are symmetrical. So that's a very important piece, that where you want to place them. And then you want to use different way of, like, for example, shear wall, or like, for example, a single bracing or cross bracing, in order to create that lateral stability to your structure. But when you're adding those elements, the biggest challenge is that you are creating some architectural limitation, including, like, for example, when imagine that on one of my span, I put this cross brace for my structure. What's going to happen is that on that specific span, I cannot put the window in the middle, right? Because there is a brace coming, crossing. So these type of things that you have to think about. One of the good places to bring the lateral stability to your building is wherever you have the staircase, because the 3 or 4 side of the staircase, it can be easily reinforced all the way through all levels. So that's one good place for the bracing. Again, refer back to the chapter in the book, but before jumping to this part, in order to add our bracing, one of the options to do that is that instead of doing it in the floor plan, it's better to do it in elevation, obviously. So you can create like a sectional, like a framing elevation, and looking from the framing elevation by going to the view tab and creating on the framing elevation, and start adding those structural elements that you want, the bracing elements that you want. So if I go here, and right now for this structure, because I use the concrete, I don't need to have like a have a bracing, but for the sake of conversation, I just want to show you that you go to the elevation here, you go to the elevation framing, and then if I go closer to one of my frames, you see that it's just that frame highlighted. So let's say I decided that my bracing is going to be on this span. So I go here closer to this one, click, and that's going to be obviously my first elevation for the bracing. So if I go back down here, you see that I have now on the project browser, I have the framing. I can click on the framing and I see that. And then if I want to add, sorry, if I want to add the structure, I can go here and add the bracing. I mean, obviously this is not working for this one because it's a concrete, but obviously, and this is going to be easier to manage where I want to place my bracing on this one. So if it is going to be going halfway or going all the way to this side. For concrete, it's not this way unless you want to create some sort of a cantilever or something. But that's a different story. So assuming that, for example, you have a steel structure, that's the way of doing this part. And then the last piece is adding the floor slabs. And the floor slabs is obviously again through the structure, you go to this flooring slab, and then different flooring type that you have, you can either use it as a one-way or two-way, and using the grid for defining the boundary. It's not that much of a different than how you create the floor in your architectural system. It's the same thing. The only difference is that it's going to be structural. So the format will be structural. The thickness is coming from your research, and you want to use the grid instead of, like, for example, the regular way of like putting your floor system into the Revit part. Okay, so this is go through that piece, like for example, different elements that you want to have, and then the type of the span that you want to have. If it is going to be one way or it's going to be two-way slab. And I put at the end of this as very good video, which is not required to do for this class. It's obviously, I just put it as a reference for you, is like it's going through some structural detailing, which I find it very interesting that, for example, if you have a steel structure or something and you're looking for going more advanced, this is, I think, is a very good like a video. I put it is for Autodesk, and you can go through that part. But for the purpose of this class, we are not going that much of a detail because we are not actually doing any sort of detailing for a structural system in this class. All right, I'm gonna say stop.